Okay, 12.2 measures of central tendency. It's a very wordy way of saying that we're going to start looking at mean and median and mode. And the reason why we give it this fancy name is that quite often when we present these things, we present them as different things. They're obviously different things. They're different words that we do different processes to get to them. But at the end of the day, they should be all looped into this category of the goal is to kind of describe a bunch of data or results or survey answers so that we can kind of get an idea of what is the middle of this data, which is kind of a bigger question than it seems initially. So the most common form that we use is kind of the mean. We've talked about this before in class. This is the fancy formula for it. You sum up all of your terms, you divide them by the number of terms that you have, and you get your mean. So if I was looking at 3 exams, I would total up the scores of the exams, then I would divide it by the fact that there is 3 exams, and that would get us our mean. And this is typically what people think of when they think of the word average. But again, average is also kind of a blanket term that is a little bit misleading. And since we've already done some mean in this course before, I don't think I have an example of this, but I do have an example of calculating the mean when we have a frequency distribution. Now, it might be worth mentioning what a frequency distribution is it's kind of a way to keep track of your data. So we've probably talked in class already about the statistics project of you probably should loop or group up your different answers into maybe 3 or 4 or 5 categories, and then record the number of responses. So back to kind of the example of the test exam in the previous problem, it's pretty doable if I only have 3 exams, but what if I'm talking about 50 or 100 exams? And so sometimes we use this formula down here to group things together and figure out the overall average. And so that's what this fancy formula means. It's X bar, and X bar shows up a lot, X with a bar over it, shows up a lot when we're doing actual fancy statistics. And we find that by taking whatever data value we have, how many people got an 80 on their exam, and we multiply it. So if 80 is the score and 5 people got it, 80 times 5 would go into our problem. And then we sum up all of these together and we divide by the total amount of data points that we have. And so all of that's a very long-winded way of saying something. Let's get it into practice because it's not that terrible in practice. We're kind of spoiled the answer. That's fine. And so here I have a frequency table. And I don't know, let's say that we're using that. I think on the exam we had a spinner that had 10 total spots, and we spun it a lot of times, apparently 151 times. And so what this frequency table we would do is we would spin it. If it shows up for 1, we would put a 1 in that spot. If we spin it and we keep spinning it, and over the 151 times it lands on 2, 3 times, we would say put the frequency, the f of that value showing up is 3. And so that's kind of how this table breaks down. I spun 0 twice, I spun 1 once, I spun 2 3 times, I spun 3 12 times, so on and so forth. And so to figure out what my actual frequency mean is going to be, or what did we call it? A mean of a frequency distribution, is I need to figure out how often something actually showed up. So since I only had 0 being spun when I spun it twice, I would do 0 times 2 and then 1 times 1, and then I got 2 3 times, so I do 2 times 3, and this is all the way down on my table. So I have to do this for all of the values because this is kind of giving me the true overall total of my scores or my spin results or whatever we want to talk about. And then we take that result and if we sum up that entire right column that we have here, we get 975, and we spun a total of 151. If you don't want to take my word for it, you could add up all of the frequencies, the 2 plus 1 plus 3 plus 12 plus 16, but it ends up being 151. And so to figure out your mean, you do 975 divided by 151. The alternative, if we're going to use the classic definition of mean, is I would have to kind of in my calculator type out all of the possible things. So I would have to type up 151 things, there's a good chance I'm going to make an error along the way. Where at the table, yeah, there's a lot of stuff going on, but at least we can kind of backtrack and kind of see, oh, okay, did I do 9 right? 9 shows up 15 times. Okay, I did that correctly versus 150. I think my calculator would actually kind of stop if I tried to add all of those things together. Maybe not. Graphing calculators can kind of do a lot of things. And so this is something that you'll have to do with the project. Granted, you don't have 151 data points. Maybe it's 50, and maybe your values aren't quite as, I guess 10, 1 through 10 is actually fairly small. But maybe they'll be a little bit more manageable. Maybe if you're only looking for 4 results, you'll get 0 to 4 or something, or 1 to 4 or something like that. So, but this is important. In short, you're going to somehow tally your results, and you're going to find your mean, and you should be finding your mean using this strategy. Now, the other measure of central tendency we're going to talk about is median. And median, once you set up the problem, it's generally pretty easy. Median is kind of the center of the data. If you line it up and kind of knock off all the numbers below the very middle of the data and all the numbers above the very middle of the data. And so with that in mind, you have to arrange your data. So in this case, on A, we have 5 points. We have 84, 90, 98, 95, 88. And so my median is going to be, once I arrange those from smallest to largest, it's going to be my third term. It's going to be my term in the middle. And so that's kind of the hard part about median, is if you have a lot of data points, ordering them from smallest to largest honestly isn't the easiest task in the world. So that takes some work. But once you're beyond that, you generally either just look at the middle and say that's what it is, or you have a case where we have in B, which we'll talk about shortly. So exactly what I was talking about in case A. If I take those pieces of data, I arrange them from smallest to largest, I would get this list right here, and the middle data item is 90. Cool. Now, the next thing is sometimes when you rearrange things, you don't have a single middle point. So on part B, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 pieces of data. And so there isn't really a middle. There's kind of 5, the 5th place and the 6th place. And so when that happens, when there's not like a set middle part of your data, you take those 2 middle values, add them together, divide by 2, and you get your answer. So here, we arranged our pieces of data. We find that both 28 and 34 are in the center. Again, we want to maybe look a little bit more closely. There are 4 things below 28. There are 4 things above 34. So there's really no strict middle of this data set. And so what you do is you just add those two. We added 28 and 34 together, divided by 2, we got 31. Now, again, kind of tying back to the big picture of what's happening right now. Of measures of central tendency. The mean is very popular because it does have a lot of applications, but that doesn't mean the median also doesn't have a lot of applications. For example, for me, when I'm kind of looking at test scores, I tend to not really look at the mean, because sometimes I have to enter in 1 or 2 or 3 zeros into my scores, just because maybe people didn't take it or for whatever reason. And so that's going to make my mean seem like a really low data point, when really maybe the people who actually showed up did pretty well on the exam. And so what median allows me to do is kind of, median allows me to do is it kind of allows me to chop off those bottom points and say, I actually don't really care about those guys. And oh, sure, maybe like 5 people got 100, which is really great, but maybe they're people who have already taken the class or something like that. And so it allows me to kind of ignore those outliers a bit and shoot for the middle. Outliers kind of is a value that doesn't really make sense. It seems like maybe you recorded an error or something, but that's a discussion for a different day. Okay. So we could also potentially have to find the median for a frequency table. So this, I don't know if it's the exact same table as the previous example. Looks like it might be, or the previous example when we were dealing with mean. but the process or the concept's the same. We have a lot of data that we're gathering right here. We have 151 students responding to this amount of stress level that they are going through. And so it's kind of hard to look at where the middle of the data is. And so one of the options is you could take out a very large sheet of paper and start writing and say, okay, the smallest value is 0, so I'll write 2 of those, and then I'll write a single 1, and then I'll write 3 2s, and then I'll write 12 3s, and continue, and then you can kind of cull until you get to the middle piece of data, which is fine, but you have 151 things to deal with. There's a good shot you might miscount somewhere along the way. So instead, what you can do is you can kind of take advantage of the fact that you know how many data points there are. And honestly, you can use this strategy on the previous examples too. And so here's what we're talking about. Here's one of the examples of I can write out everything that we've done, or I can figure out that since I'm dealing with the median, oh, did I go to a new slide? Oh, I did, okay. So this is the same problem. So I know that I have 151 pieces of data. That means that my median, what I do is I take that value, I add 1 to it, I divide by 2, and so that tells me where it's going to show up. So again, maybe we see this in the simpler example here. So here I have in part A, I have 5 values. So my n is 5, I add 1, that gets me 6, I divide by 2, I get 3. So that tells me that the middle of my data, that the median will be in the 3rd position. Seems kind of silly here because we can just kind of look and see that, but when we get to big data points, that's how this formula works. Okay, big data points, big data sets. And so that's what's happening here again. I have 151 data points, and so n is 151, I add 1, I divide by 2, I get 76. Now, this gives me a couple of options. I can do what they did, which I'm not crazy about, of kind of counting each spot, 1, 2, 3, 4, 5, up to 76, which is kind of a headache. Or instead, what I can do is I can kind of, how I solve these guys, is I pull out my calculator and I start adding things. And I'm going to keep adding until I go over 76. 76 is kind of my goal. And so I look at my data points, I have 2 zeros, so I would do 2 into my calculator. And then I have 1 1, so I would add 1 into my calculator. And then I have 3 2s, so I would add 3 into my calculator. And so now I'm at 6, so I'm not anywhere close to 76. And I would repeat this process of kind of adding numbers down my table. And I would see that once I get to 6, I would added all of the previous values, I get 65. Then if I add 31 to that, I've overshot my 76th data point. And so that means that my median was somewhere in that kind of in between. And the only thing that's in between those is 7. So this is very much something that might look better when we practice it in class. So if that didn't make sense, that's perfectly fine. This honestly is probably, in my opinion, the hardest concept in this chapter. And it's a really big data set. So I think it'll be better when we're all kind of together being able to go through the steps of throwing in the calculator. So long story short, either way you want to do it, add it up like they did, which sounds like a giant headache. Do it my way, which conceptually seems kind of difficult, but in my opinion is less of a headache. Either way, you're going to find your 76th data item is 7. And so the good news is this isn't going to be on the project, this is going to be on an exam, and so you might have one question on MyMathLab is the only thing you might have to be concerned about. Okay. And now the last measure of central tendency is the mode. And I think this is what a lot of people think is the easiest thing to find because, I mean, the mode is what shows up the most often. And so it also doesn't really seem like a real measure of central tendency. Like, how is this describing the middle of my data or something like that? That's kind of misleading. Maybe it's a little bit more specialized than the other cases, but it certainly has its value. So what's a good example that I could think of right now? Like if you were at an ice cream shop and you were going through and you're selling your ice cream, and let's say you gave each of those ice cream values a number or whatever, well, your mode is going to tell you what sold the most. And in fact, in that example that I just gave, the other two are kind of meaningless because you just kind of gave vanilla 1 and chocolate 2 and Rocky Road 3 or something like that. But the mode tells you something very valuable there. It tells you the most popular flavor, and so you might want to stock more of that. So it is, in a sense, it's a measure of central tendency. It's a little bit more specialized, but it does belong in the group of median and mean, and they all kind of have their individual values. Sorry. And so all of that's a very long-winded way of saying, I ramble sometimes, that when we have data points, finding the mode is we just add up, or we find the most common number. And so for the first case, I have 2 7s. Every other data point shows up ones, so two, or a single 2, a single 4, a single 8, a single 10. And so my mode is 7. Great. The second one's a little bit weird because I have 5 different data points, but they're all different values. And so some people would argue, and honestly, if like this were an exam or something, and you said the mode would be all of the numbers, it's kind of true. They all show up an equal amount of time, but this example is pulled directly from the textbook. And so since MyMathLab is probably the thing you're going to be most graded on in this section, they'll probably want you to say that there is no mode. That being said, I guess I am grading something. I'm going to be grading a project, and I can't really imagine this happening, but it's possible that somehow your data magically lines up that all of the values are the same. Then that's fine to say they're all the mode, or there is no mode. And then in the last case, you can have more than one mode. And so this is something different from the median and the mean. You're only going to get a single value ever with median or mean. If you do get 2 values in median, that means you have to add them together and divide by 2. Where with mode, we can have multiple ones. We could have, in this example C, we have 2 modes, 3 and 6 show up pretty often. You could have 50 modes potentially if you had a lot of data kind of flying around. And so when that happens, there's a fancy word for saying that the data is bimodal if it has 2 modes. I'm sure there's fancy terms for 3 and 4, trimodal or something weird like that. But, and I probably should have led the lecture with this, but something that I'm realizing that I may have never defined is data. I keep throwing around data. Data is just any like information that you've gathered about your survey. So if you're asking people yes or no questions, the data is their responses. They said, yes, that's a piece of data. They said, no, that's a piece of data. Or in this case, they're just numbers. We're looking at 5 different numbers in B. So my data is each of those pieces of numbers. So I think that's a word that gets thrown around a lot that you probably have figured out through context at this point, but it is worth mentioning what it actually is.